Welcome to another video in this big O notation series, and in this video we are going to visualize and explain the big O of 2 raised to power n, which is the exponential time complexity. So an algorithm with the big O of 2 raised to power n doubles its runtime with each addition to the input size. So in simple explanation, it means that the calculations performed by an algorithm double every time as the input size grows. So in addition, right, when an input has been added, right, the growth rate doubles and the algorithm iterates across all possible input elements. So when an input unit is increased by 1, the number of operations executed is doubled. We can look at this growth rate. This is actually designed by me for explanation purpose. So if you look at the growth rate, right, you can see if you pass in an input of 2, the growth rate is going to be 2, which is this 2 multiplied by the multiple of 2 of the input, and in total it's going to give us what? 8. So the growth rate is going to be 8 at worst case scenario. If we pass in 4, for example, right, the growth rate is going to be 2 to the input, right? 2 multiplied to the multiple of 2 of the input, and it's going to be 32. If we pass in 8, right, the growth is going to be 2 multiplied by the input in multiple of 2, and it's going to be 512 at worst case scenario. So guys, if we look at the example I have here, so this function is going to print out all possible combinations. So if there is no input, it's going to print out nothing. So if there is an input, which means a single input, it's going to print out a single input. So if there is 2 input, that means if we pass in 2 input, it's going to print out all possible combination of that input. And we can see we have A, we have B, and we have AB. So if we pass in 3 items, right, for the input, it's going to print out all possible combination. You can see the runtime will grow as the input time increases, right? So this is a clear example on how the big O of n raised to power 2 works. Next, let us look at code example. I am currently on my VS Code, and there is a function, right, which says generate subset. The name of the function is generate subset. So in this function, what we are doing is the input element, we are going to take in the length of the input element, which is n. So we want to print out the subset, which is the possible result of what the input element, which is the possible combination. All right, so what we are doing here is we are looping, right, and multiplying the value of n by 2. So there is a subset, right? There is a subset for this, and for every element, we are actually looping and setting the value of that subset. So let me run this function, and we're going to see it in action. So there is a growth rate which I added here just to count the number of loop that is happening in this algorithm. Before I run, I want us to notice the input. This is the input set, right? You can see, and this is where we are invoking the function. We're passing in the input set. Okay, so we are sending 2 elements to this function. So let me run. The result we are seeing here is, first of all, it prints out an empty array. Next, it prints out 1, which is this. Next, it prints out what 2, and next it prints out what 1 and 2. So it prints out all possible combination of the given element. The loop that happens in this algorithm is what? A total of what? 4. All right, so let me pass in another input. So this time I've increased the input size to 4. So we are passing an input which is an array of 4 elements to this algorithm, and let us see what we get. Let me clear my console. I'm going to run. I want you to take note of something, right? So it prints out an empty array. It prints out one, two, then it prints out one and two, it prints out four. So basically, right, what is going on here, right? It prints out all possible combination. So this algorithm is going to print out all possible combination, and you can see the loop that is going on inside this algorithm. That is the loop that this algorithm used to achieve this result is 32 loop. We can see that. So which is the growth rate? So the loop grows by what? 32. Let me increase the input. So I'm going to increase the array elements to 8. Let me comment out this and run. Let me clear my console. We can see the input size grows and the result also grows. So the more input we put, the more results we are going to get. Okay, so let us see the loop that happens inside the, the algorithm. You can see to achieve this result, the growth rate is now 1024, right? So this algorithm make use of 1024 loop to achieve what this result, and all possible combination is printed out. It is important we avoid this kind of algorithm because its growth rate is higher and it doesn't scale well. So it takes a lot of time to process its output. So you can see with just 8 elements of an array, it's printing out a whole lot of this, and the the growth rate is 1024, which is not a good one. So supposing, right, we supposing we have 20 elements, right? You can just imagine how much the growth rate will be. So this type of algorithm is not going to scale. So we should try and avoid this type of algorithm. An algorithm that has the runtime complexity of big O of 2 raised to power n, which is the exponential time, should be avoided. So next we are going to the big O sheet. So if we look at what we have here, you can see this is the position taken by what? The big O of 2 raised to power n. You can see at the beginning, right? At the beginning, it kind of a little bit curve, right? You can see the curve, right? It goes to the right side and it's skyrocketed up. This kind of algorithm is not going to scale. So guys, that is all for this video. Thank you very much for watching. I'll see you in the next video.